Hello, hello everyone. This is episode number 29 of the Amiga 68000 programming in assembly series. Thanks to Fabio Ciucci for letting me and giving me the permission to do the streams using his book. His book is in Italian, as you know, but the code in 68000 is always 68000, doesn't change whatever language we speak, but machine language is always 68000, and anyone that follows me should be able to understand the code. So there isn't any issues from that point of view. Okay, so we will continue where we left in episode number 28. Remember, this is episode number 29 of the Amiga 68000 assembly programming series. So we need to go to the book, which you are and I'm not. Okay. We are, if you recall, we are in chapter 8 and we were creating a startup file. This startup file, we basically did it, we tested it, and we did, the last one we did was lesson or example 8b. So we have arrived to another section, which is we tune the part where we were let's say talking, or how to say, before we had a routine that dealt with the vertical blank, or where the raster line, where it is, and we waited for a particular line on the screen, a particular raster line, and then we did our checks, and from there we waited for the raster line, and then we continued with the code. So we are going to talk about waiting for the raster line, but we are going to expand on it. If you remember, we were checking for a particular line, raster line, where the XX is, right? And we waited, and if that didn't match, we just loop back. That is what we were doing. And this was by reading the register or checking against the register. With the copper, we can do something similar. If you recall, the copper, we wait for FFF, okay, DF, okay, and then of course after FF it jumps to 0 0. So if we try to wait for a raster line that is above 255, we can have issues by doing just this check. Remember, this check, okay, this check where the x-axis gives us FF. So the copper knows that when it reaches FF, okay, it starts again from 0, but actually it goes to 256. Okay, raster line 256. But we still write 0, 0, it just knows, right? Example, okay, if we want to wait for line 256, we wait here where the DF is, and then we write 0, 0, and that means we are waiting for line 256. If we add 1 to it, or 1, that means we are waiting for line 257, 101 in hex. So I need to show you a little diagram now. Let's switch you to the whiteboard. Okay. I do not have the pen with me, okay, so it's already packed. Remember, I'm moving house, so all this happened at the right time. Now to have a hard disk crash really happened at the right time. Anyway, so let me explain what I'm trying to tell you. Okay, we have a raster line that starts at 0, 0, go to FF, then starts again at 0, 0, and then goes to 38. 38 is the last line, the raster line. After that, it resets back to 0, 0. So, if we ever had to wait for a raster line 0, 0, between 0, 0 and 38, we will be executing that code twice in one frame. The reason being, from here to here is 0 to 38, and from here to here is from 0 to 38. So that means that we have some type of bug in our raster line routine, which we will need to fix. Okay, so we are going to improve it and make sure that this condition we don't have. Okay, as you can see, this creates us a problem because it's we run the same code twice in one frame. Notice also that one frame, okay, one loop of the raster line is from 0 to 138. Okay, that is the raster line 138. After 138, we go back to 0. So if we try to do a check for 139, okay, note also that means that will never happen, and that means our we have an infinite loop, because we'll be checking for 139, but 139 will never happen. Hence, we need to be careful not to exceed the 138. So, another thing to keep you in mind, okay, we have the registers, okay, we have DFF04, 004 and DFF006, but these are word registers. So the memory location DFF004, the 1 byte at DFF004, we are not interested in. But at DFF005 we are, because there is bit 0, which is the high bit, okay, which for the raster line. So if we want to know if we are in this zone, we check for this bit. DFF006, we need the byte because it's from 0 to 255, okay? But DFF007 we don't need, okay? We are not interested in. So basically we work on DFF006 as before, plus the bit 0 in DFF005. That's, I think that is, I hope that is clear. So let's go back to the book. So what is Fabio telling us? Okay, so actually it's here. Okay, so DFF006 behaves in the same manner as we were used to, okay, from 0 to 255. However, it doesn't go to the top of the screen, but continues, okay? So when we were checking, okay, we were only reading DFF006. So after 255, okay, it didn't go to 0 as we were thinking, but it went to 257. That's what Fabio is saying here. It doesn't go to the top of the screen after 255, but it continues further down, okay, from 256 to 257, etc., etc. It continues going down till raster line 138 hex, okay. Once it reaches raster line 138 hex, it goes to 0, to the top, okay. This means that our routine can be executed twice if we do not check for the high bit, okay, of which is in DFF005, okay, which you see it mentioned here. So we need a routine that will be able to handle 312 lines, okay, because we have from 0 till 312. 313 we cannot check for it, it doesn't exist, okay. So we need to use bit 0 of DFF005. We can browser, I need to go to the browser too, go to DFF04, okay, remember they are word, so we'll need DFF005, okay, and we are going to see that bit 0 is for the high bit of the raster line, okay. There are also others, but ignore, okay. This is not OCS ECS, okay. We are just programming OCS ECS, okay. So that's the bit that we are interested in. We go back to the book. So he shows us what I showed you in my whiteboard, no, the registers, okay, DFF004 and DFF006, which are word, but hence the bytes are DFF004, DFF005, 06, and 07. We are interested, okay, in DFF005, and which is bit 0 of DFF005, and of course DFF006. DFF004 is VPOS, no? VPOS R, and those are the names that they use, okay? And DFF06, of course, and 7, because these are where it's called VHPOS R, okay? To wait for line 256, we can do the following. We can test, okay? Bit test, remember BTST, we are waiting for bit 0, okay, of DFF005. We test for it to see if it is a 1, okay? If it is set, then we continue with our code. If it is not set, then we jump back, okay? We go back. Here you can see wait VBL, we go back. Till it is 0, we go back. So that is how we can wait for raster line 256. Hence, we have arrived at a point that we need a universal routine for our raster line checking. Here is how our universal routine looks, and this is the first iteration of it, okay? Remember that in A5, okay, we have our base address of the custom chip registers, which is DFF000. Hence, for A5 means DFF004, okay, because we're adding 4 to the DFF000. So we load the value of DFF004. Remember, it's a long word, okay? So we are loading the registers because we are DFF004, okay, and DFF006, okay? We are loading them both into the 0 because we are doing move long. Then we shift, okay, by 8, so to the right, okay, logical shift right. So we drop the first byte, the first 8 bits, and what remains is our bits that we are interested in for the raster line. And the result of that, we will end it with whatever, with 9 ones basically, okay? The reason why we do this is so that we just have the result of our 8 bits that we want, okay? Sorry, 9 bits, okay, that we want, and everything that is 0 in front of the ones here becomes 0. Remember, AND gives us sets the bits to 1 only if both of them are 1. So after we did that, we check if we have reached line 300. If we did, we continue with our code. If we not, we go back to wait y. The most important thing is to notice that from the FF004 we are loading 4 bytes which are of register DFF004 and DFF006 in this case. So remember that an AND gives us a 1 only if both of them are 1. Hence, further down, he's going to explain what happens. Okay, here, I mean, I didn't. Yeah, here he explains the end. Okay, and he's just said this part, you know, that is in capital is when both of them are 1, we get a 1. So we get the result by this. We get the result, okay, ending these 1, putting these 1, 1, 1, 1, and the rest of zeros. We get the actual bits that we want to work on. Okay, however, that was in binary. This is in hex. So 1FF. Okay, so this up here and this here, they are the same. Okay, one is in binary and the other one is in hex. So maybe it makes more sense seeing this in hex than in binary, but they are the same. Okay, so now that we know this, we can actually remove this instruction, okay, the logical shift right. Okay, we don't need it. We can do without it. How? So this is how we're going to optimize the code. We can do an AND with 1FF, and the bytes that were in front of the 1FF, which we did a logical shift right, we don't need to do that. We just put a 0, 0 in front of it. Then when we want to check for line 130, we add also 0, 0 there. And like that, we've shortened our code by removing one instruction that we have here. Okay, so this code and this code are the same, do the same thing. It's just that this is faster. Let me see that I said everything that I needed. Yeah. So here we are waiting. Okay, here there's he has 255 here. Okay, so we are waiting for line 255 here. He has a small mistake in the book. He wanted to say line 130, but he wrote OFFF. So it's either this right or this right, whichever, but we know what he's trying to say. So he advises us to use this routine, okay? Or we can use what was in the source that we saw by using 2 additional registers. So whichever, either we use this routine here or the previous one, as long as we do not fall into the trap of running our code twice on the same frame. We can improve this routine, okay, this routine a bit further by moving what we need to check against in the data registers. Okay, so remove the 1FF00 into 1 and move long the 130 line 130 00 in T2. So now, as you see, the loop is shorter and quicker. As you can see, everything is done using the registers above. Okay, so that's why it is quicker. as stated, be careful about A5 and A6 registers, because normally A5 contains DFF000. You can see it here, okay? And A6 is the address of the exec, okay? So it's like a standard, it's like a known standard. It's not that you need to follow this, but it's what they do normally. Do not, and I put this in red and quite visible in red, do not check for lines, raster lines above 138. Because if you check for line 139, that raster line does not exist and you have an infinite loop. So be careful to always be between 0 and 138. If we have NTSC instead of PAL, because that 138 is for PAL, for NTSC we have 1DC, which is 106. This is where you switch to NTSC, the register DFF1DC, okay, and this is the limit 106, okay, hex. I think before, sorry, I said the limit is 1DC, but actually this it's the register 1DC, okay, and the limit is 106. Okay, so we learned how to have a proper raster raster line, how we wait for a particular raster line properly. However, this chapter is the only chapter that doesn't have sections in it. So when you see blue on the left hand side, like here, fade routine, it means I'm going to start a new section, and it is to remind me what there is in chapter 8. So basically now we are going to talk how to create a fade in and a fade out routine, okay? And this routine we will use it inclusive with our startup file. Remember, we just saw the startup file, how it works, but now we are going to use it with proper code that we might write, okay? So we will be doing that now. Okay, now that you know about the AND, OR, and LSR, and let's see how we can use them better, okay? So basically, we have spoken about AND, OR, and logical shift right, etc. But we haven't really used them in a proper routine. So the fade routine is where we will use them properly. So we have an image, our logo, let's say, and the logo will start black, you know, will be all the colors will be 0, okay, and then they will start incrementing till they reach their color value, okay, and that is called fade in. It's coming in, no? When we are leaving, when we are checking from our color, the current color, let's say our color is red, and then we are decreasing it to 0, that is becoming black, that is fade out. Okay, so let's talk about a fade in first of all. As you see, we have our colors starting, okay, as you see, this is our colors, 180, 182, etc. And they are all starting from 0. What we need to do is where we have 0, okay, we will need to put our color there somehow. And remember that the colors are in the form of red, green, blue, RGB. And the colors will be incremented to the value, to the final value, okay, every frame, okay. So let's say we have a value of 8, so the first frame will be 1, the second frame will be 2. Remember, we're starting from 0. 3, 4, 5, every frame we increment 1. Now, I'm not technically correct of what I'm saying, but for now, in our imagination, okay, in our virtual world, consider it that it is correct. So here we have a table with our colors. This is the values of the final values that we need in our table, okay. If you notice that color 0, 180, is black, but the others are all a higher value, okay. Normally color 0 is always black, okay. So just let's play with that for now, okay, that our color is black. So from that table that we had here, we create another table with a list of our colors, okay. And notice we skip color 0, okay. So the 0, 0 of 180 is not there, but we start from 182, which is FFF, and we created a list of our colors. This is where we need to arrive, our destination from 0, okay. We will always start, okay, in our, let's say, fade routine from color 1, which is color 182, okay. To do this, okay, it's very simple. We just need to to create this table. It's very simple. Now we take the color that we have, the color table that we have here, and we just we remove the register value, and we create our colors. So it's simple to do. Okay, so now we need to work on the colors. We need to work on each component of the color. So we need to work on the red alone, the green alone, and on the blue alone. Not all three together, but one at a time, okay. Imagine that 80 holds the address to our table, to this table here, okay. So the first address, the first value that is going to have is FFF. We need to work, let's say, on the blue. So to get the blue only, we do an end.w 00f, and you can see it here. So we loaded the color from the table into the 4, and then we are working just on the blue because we had 00f, okay. We ended everything and we said, okay, we want just the bits that are related to the blue. So this is how we will be doing. We will do this for the blue, we will do this for the green, and we'll do this for the red. If we had the value, okay, 1 2 3, okay, in our table, and we just needed to have the blue, okay. With this routine, these two lines, it will gives us the tree, okay, because we are ending the 00F, okay, and it gives us the bits set for the last nibble. So we will end up with 0003, as he says here. If we wanted the green, instead of ending with OOF, we will end with OFO. And if we wanted the red, we will end with FOO. Okay? Simple, no? Now, in our virtual world, okay? We continue in our virtual world. To simulate our fade routine, okay? We imagine that each time, every frame, we increment the value of our color by 1. Okay, so if we had the value 235, okay, we increment 1 the red, 1 the green, and 1 the blue. Okay, then we increment again the next frame, and both of them becomes 2 2 2. Okay, then notice the red doesn't need to be incremented anymore. Okay, because we have reached the maximum of it, but we need to increment the green and we need to increment the blue. Then we arrive at frame 4. Okay, we do not need to increment neither the red nor the green, but we need to increment the blue. Once we've done that, we arrive to the maximum that we need to increment, because our final destination was 235. So this is how we will do it virtually. Now, this thing in our head might work perfectly, but there's a slight bug which we will come to it in a minute. So it is not 100% correct, and you'll see why in a minute. We need to add 1 to each component, okay, which is 1 to the red, 1 to the green, and 1 to the blue. Once we do this, okay, we need to actually OR the values together. Okay, so when we were doing this, okay, we were doing this part, okay, we were ending up, okay, with separate values for the red, for the green, and for the blue. So to get them all three together, we need to OR them. Okay, so it's another way. Okay, I remember I told you we're going to learn how to use the AND, OR, and logical shift right, okay, in more detail. So we end it, and now we are ORing them to join them together. That's what it does, what we need to do. This in principle, okay, not in reality, this works in principle, okay, but in reality, as I said, it has some issues, especially if we need to use AGA. Right now, the issue will not be so evident because we are not using AGA. So we need to know how many times the routine is going to be called, okay, and basically we know that by checking which is the highest value. In our table we have FFF, we have white. if you remember, which is color number 2, it's FFF. So we know that we need to execute our routine, this routine, playing it in our head, okay, to arrive at FF 15 times. So all colors are faded, are 0, and then they will start being coming up to light, let's say, okay, by incrementing our 1 on each one of them. And once we do that, we make sure that we don't overgo to the color, but some color like the white, which is FFF, we will need to continue to do that. So our routine needs to do it 16 times for sure. If we had to do fade out, okay, instead of fade in, so from the color that we have to 0, we will have to do the same things. No, we have to do it from 15 to 0, so 15 times still. So it's the same thing both ways. We need a way, okay, to synchronize the colors, and this is where we have our bug right now. Okay, we don't actually have, okay, the routine working properly, but we will manage to have it working properly by synchronizing, and I will tell you what I mean by synchronizing. There is another word that we can use, like equilibrium. No, we can make sure that everything is equal or proportional. So I already mentioned that we need to know who is the highest. We need to know what is our highest number. Okay, in that case, in our case, how many times our routine is going to loop, and that is 16 times. So we create some type of variable which we call it fase del fade. No, here he's calling fase del fade, which means phase of fade, let's say, if I had to translate it. And we are adding 1 each time. So we start from 0 and we add 1 each time. Remember, the routine is not 100% correct, but for now, let's go with it. So we know that this number cannot exceed F. No, we cannot exceed more than 15 times. Okay, so let's say, okay, we have the number, the color 084, which he mentions here. Okay, if we increment 1 each time for the, we are only using the green and the blue, right? So if we increment 1 each time, we go, remember, we are using our virtual routine, we go from 1 to 4 for the blue, and then we stop incrementing it, but we continue till 8, okay, for the green. However, this is not correct, because when the green is 4, okay, to be in sync exactly, okay, the blue needs to be 2, not 4. So we need a way of synchronizing this. Okay, I'm going to read my notes. So on the first frame, we will jump to our routine with fase del fade and add 1. So we are adding 1 to each one. Second time we add 2. You will notice, okay, that we have a bug. When we arrive at 4, so the blue is at its maximum value, which is 4, but the green is only half of it. It should be the opposite way around. It should be the green should be 4 and the blue should be half of it, so that they are in sync, so that they increment at the same with the same level. So as I said, when we are at 4, okay, when the green is 4, the blue should be 2, so 0, 4, 2. Now, how can we solve this problem? Well, what we will do is we will use fase del fade as our multiplier. We start from 0, okay? We increment, and when we have 1/16, so the process is we multiply by 16 and we then divide by 16, but you're going to see what you tell me it's the same thing, and now because you're going to see what we are going to do. Notice the code that we have here. The 0 in this case will hold our multiplier, which is fase del fade, no? So we read the color, okay, and we put it in the 4, okay? Then we end, so we are working on the blue here, okay? We are going to get the blue component and we store it also in the 4. So now the 4 holds only the blue component, okay? Then we multiply the value of the blue with our fase del fade, okay? Whatever, if we are in iteration 1, we multiply the value in the blue by 1, by times 1 basically. If we are in iteration 4, we multiply it by 4. However, after that, we divide by 16. The arithmetic shift right, okay? We are dividing the result of the multiplication by 16. That's what it does, arithmetic shift right. Hash 4 is because we are shifting 4 bits, and that means 16, okay? Once we divide by 16, okay, we end it again, okay, to get only the blue value. Basically, we get the actual, because there can be a remainder, no? We just want the actual fixed number. And basically we end the result back and store it in D4. So now we have the blue, okay? And then we store our calculation to D5, which is the blue component. Now we need to do this routine, okay, 3 times. We need to do it for the blue, we need to do it for the green, and we need to do it for the red. Yes, I used to. You're asking source. Okay, sorry. I was going to. I thought you were asking me, Nemo. Sorry. So this routine, we need to use it 3 times in total, and we need to do it for each color, or each component, not color. So here he's going to explain what I just explained, so I'm going to read it quickly. We are multiplying fase del fade by 16, okay? Sorry. We are multiplying the component, the result of our our component, whatever that is, whether it's green, blue, or red, to the value that we have in fase del fade, and then we are dividing by 16, which is done, the division by 16 is done using the ASR.W. So basically he continued to explain what I just explained. So instead of using arithmetic shift right, he's saying, so here we used ASR, no? And we did arithmetic shift right #4. We can also use divide DUV instruction, okay, which is division by 16. I think ASR is faster, okay, but we can use that. With this, we have our fade routine. Basically, this is the trick. We multiply by fuzzy del fade and then division by 16, and like that we always get the right value. So when we had this, okay, when this was 4, okay, this will be 2, okay. That's how it should be, so that we see a uniform increase of the colors. Now, as we are doing from 0 to the color, we can do it also fade out. Now we can do from the color to 0, and it's the same routine but inverse. So, and you are going to see this in the examples that we are going to go through in a minute. So that is how to do a fade routine, and I will go also through the code now, but the theory behind it. Okay, so let's jump to the Amiga. We have two examples to do, lesson 8C and lesson 8D. So let's go to the Amiga, and I need to be on the Amiga. Okay. Sorry, RamJam I need. And we are in Sergeant 4, and we need to do C. So we assemble and we execute it, okay? So notice on our screen we have nothing yet except some copper bar, but we are going to display our logo on top of it. Yes, if you type, because I do not have the luxury of having many moderators, the bots will stop you if you try to write too many capital letters. So once I press the mouse button, notice how our fade routine is going to work and our logo is going to be displayed. There you go. So you can see the logo of RamJam. Remember, these examples are from the book, and this is the logo of RamJam that they had at the time. And notice how from black it came to the colors that it has, and they were uniformly increased. Okay, and we are going to do the same thing, but now fade out. Okay, so we are going to fade it out and exit our routine. Okay, so you can see that from its colors it went back to dark, and we exit our routine. So I'm going to leave it there. Okay, but let's jump to our code, to our examples book now. Remember, the book is two books. One is the theory book, and the other one, okay, is the sources, no? So we need example comment. I need to find 8C. Okay. Okay. So this is the first routine that we have for fade in routine from black to a color. Now I need to set these settings. Okay, so remember here we are including our startup file. This is our universal startup file for when we take control of the Amiga. Okay, so here we have our normal setup routine to set up the bit plane pointers, okay, where our logo is. We are telling the Amiga which DMAs we need on, and in this case we need the blitter DMA, sorry, not the blitter, the bitplane DMA and the copper DMA and the sprites, okay, and those are defined in this equate, okay, EQU, and we are telling which ones we want enabled, okay. These are the bits that we are enabling. So we are writing that value into the register 96. Okay, so after that we make sure that we are our code is AGA compatible, so the code can run on AGA, and this is the set of routines that we need to add, well, routines, set of lines of code to run on an AGA machine. Splitter for sound, no, it was a different chip, has nothing to do. So once we arrived here, remember this is the code of our fade routine that we just explained, that you just saw, okay. Here we have our wait, so when it starts, you remember it's everything is dark, you don't see the logo. Here is where we wait for our left mouse button, okay. If it is pressed, okay, we clear, we make sure that fase del fade starts at 0, okay, and then we make sure that we reach, so here we are using the wait for a raster line routine, okay. We are waiting for line 255, okay, raster line 255, using the routine that we just discussed. Once we arrive there, our fade routine is executed, okay. Then I will explain the fade routine in a minute, but right now I'm explaining the main routine. Then we wait again for the mouse button to be pressed. We this time notice that fase del fade, it doesn't start from 0, but it starts from 16. Remember, we are going to do a fade out, not a fade in, so the inverse. So we start at 16 and we decrement one by one. Once we finish, okay, sorry, we wait for, once we set it up to line 16, okay, we wait for raster line 255 and then do our fade out routine. So one was fade in, the other one is fade out, and then once we press the mouse button we exit basically from the system. So here is our fade in routine and fade out routine. Okay, now this routine is, you are seeing the first part of it, and notice this is the fade in routine and this is the fade out routine. So, and they are a copy of each other. Okay, the only difference between them is we are subtracting one here, and here we are adding one. Okay, you can see we are adding one to fuzzy del fade, and here we are subtracting one to fuzzy del fade. The rest is the same. What we have here, so fuzzy del fade, our variable, okay, our variable is here, fuzzy del fade is this, you can see it there. Okay, this is where we are going to store our multiplier, let's say, the value that we have in the red, green or blue with the value that we have here. However, notice that the fade in routine or the fade out routine, okay, they both call another routine called fade. Okay, so we have a common routine in between, which is this one. You can see BSR to fade. So I'm going to explain that first, okay, and then jump to here. So what does the fade routine does? Okay, so the fade routine needs 4 parameters, okay, which are the number of colors that we need to manipulate, okay. Then in D7, in 80 we have the address of our table with our colors, okay, this one. In A1 we have the address where we are putting the colors in the couple list, okay, and the 0 we hold the value that we have in fuzzy del fade. So we have in the 0 we put this. So those are the parameters that the fade routine needs. So if we jump back, we see that it will set those routines will set this value, the D7, A0, A1 and D0. So we check, the first part is we check, okay, that we haven't finished our fade routine. If we finish, we don't continue, okay. But if we haven't, okay, we move fuzzy del fade into the 0, okay. Then we move the we move the fuzzy del fade address into the 0. Then we store the value that we have there, okay, into the 7. Okay, so this is one of the first parameters that we need, the number of colors, okay. Then we move the table address, okay, into 80. So this is the address, okay, of our table of colors. Then we move the destination, or the address where we are going to put the colors, okay, that we are working on in the copy list. So, and that is A1, okay. And then the 0 will hold our multiplier, our fuzzy del fade. So sorry guys, I this part I explained it wrongly. I'm just going to repeat it because I think I wasn't clear when I explained this. So the first one, we are moving the value that we have in phase del fade, okay, into the 0. Remember, the 0 is our multiplier, is the value that we have in phase del fade. Here, the move quick 50 minus 1, okay, in the 7 is the number of colors that we are working on, okay? So I hope that that is clear. The rest is what I explained, and then we call our routine fade, okay? Then, of course, we need, once we've done our fade routine, we need to add 1 to phase del fade, okay? And we loop back and we continue doing this. If we reach 17, we know we need to end till 16. We need to continue trying to increment the number. The fade out works the opposite way around, but notice it's passing the same parameters, okay? That's the thing. The only thing that you need to notice is that we add 1 to phase del fade after we do the fade, while here we do subtract 1 before the fade, but the rest is the same, okay? This line matches, this line matches, this line matches, this line matches. We compare to 0 because we need to make sure that we have not arrived, all the colors are 0. Now let's explain what our fade routine does, and you're going to understand it very quickly because I divide it into colors. So this is the routine that handles the green, the red. This is the routine that handles the green, and this is the routine that handles the blue. And notice that the routine, let's take the green, okay, is the same as what we have discussed in the book, okay? We move our color into the 1, we logical shift right the number by 4, so we divide it by 16, sorry. So here we did the divide, here we did the multiplication, and then we just take the value, okay, for the green, and we store it in the 1, okay? And the same is for the blue. If you notice, we take the value in the 2, so we are taking only the blue, we multiply it by the 0, which holds our phase del fade, okay, and then logical shift right. So here we did the multiplication, here we did the division, and then we have the value in the 2. Once we have both values, okay, the green and the blue, we OR them together, so we can store them together. Here we are just initializing our values to 0, so there's nothing to explain. The red, green, and blue are the same, okay? And then we just check, we merge the colors, and then here we just check if we have done all the colors. That's basically our fade routine. Here you can see our table with the colors, and here we can see the couple list where we are inserting the value of the colors once we are looping through the through our routine. So those are the 2 tables that we need to pass, and actually remember that we passed the address of these here. This is, so A1 is the address of our couple list, and A0 is the address of our where the colors are, okay? That's our universal routine, and we have I have explained how the fade routine works. Now that was the first iteration of our routine. No, Fabio has got a better solution, or something that which I think is better, okay, because here we need to order the values each time. Okay, if you notice, where is it? This one, this part. We need to order the values and then store them with the red, all three together, and then we can do something with the value. So I think the second routine is a bit better. So that was 8C, and we are going to do 8D. Now I'm going to show you 8D on the Amiga. Okay, so let's do 8D. In terms of what you're going to see, it's going to be the same. Okay, the difference between these two is that this routine is a bit better, at least my opinion, in relation to this. So let's jump back to the book. But we need the exercises. Okay, so the first part I'm not going to explain, okay? I already explained it. The code doesn't really changes, okay? And you can see here we have our routine, fade in, and here we have our fade out. And notice that here we initialize the fade in, fade out with the fuzzy del fade at 16, and before we initialize it at 0, here we clear it out, which I didn't highlight because it's normal. You will notice that this routine, okay, we have 3 routines, okay, which call again our fade routine, okay. This routine, okay, the fade in and fade out, are identical to what we had before, so I'm not going to explain them. Nothing changes here, okay. What changes is here and not in the parameters, okay. The parameters are still the same. So D7, number of colors, A0, address of table where the colors are, A1, address of where the colors are in our copy list, and the 0 is the value of the fuzzy del fade multiplier. But notice that for the blue, green, and red, this routine is simpler, and look, we just have the loop here. So what it does is exactly what we saw in the book, and this is basically a copy of what we saw in the book in a way. So we take the blue component here, okay, we multiply it, okay, we arithmetic shift left, we divide it by 16, okay, and we end it. So we store the blue value in D4, then we move that value into D5. We do the same thing with the green, okay, we get the green, we multiply it, we divide it, we make sure we only have the green component, and we OR it this time with the value that we had in D5, okay. For the red we do the same thing, so nothing changes, and then we loop. Nothing else. You can see that the table is the same copy as we had before, and the copper list is the same as we had before. Nothing changes. Here we have a comment. This routine is the same as the previous one, but the previous one was working on bytes, while this one works on words, and this one is better also because it is better for AGA. So when we do AGA, we will use this routine. instead of the previous one. So that's another advantage that this one has. So we did C and D. Let's see what, if he says anything else there. The difference between these two is the order in which, yeah, it's what I explained. He's thanking the person that did the logo, and we need to do lesson 8e. So this routine is also a fade in, fade out routine, but it creates a dominant color, and I'm going to show what it means by having a dominant color. So let's go back to the Amiga. So notice the dominant colors, okay? Notice that now the logo is in red, so the red is dominant. And there's a trick how to change the color from what it was originally to, let's say, in red, without actually having the logo in red, which I will show you in a minute. So this is the trick that we are going to go through. Now you will see it in green, so the green is dominant, and now the blue is dominant. Okay, this routine is quite a simple one. We will jump to the book. So this routine is the same as the previous one, okay, but the difference is that we are adding these values. Okay, so when we are doing the routine for the red, we're adding B1, 2. Notice that B is red, so B is quite high. The green is 1 and the blue is 2. So what we are doing is we take this table that we have down here, okay, we'll take this table and we are adding also that value that we have there. Yeah, I mean red, green, blue is standard, no? So that's all what we are doing, and I'm going to show you that it is the same routine as before, but notice that he is adding that value, and I think he's doing it before he calls it. Yeah, yes, you see, let's start from the red. So this is the part of the red, okay, and he's adding, okay, B12 to the color, to the original color. So basically like that, he's making sure that the original color is inflated and becomes more red than the other than what it was. And then as you see, he calls the fade in routine and then the fade out routine, doing the same thing. And then he does it with the green, same thing, but this time notice the green is 7, so he influences the color with 7, okay, and it becomes more greenish, the logo. And then he does the same thing for blue, but notice that blue is C, so it becomes more bluish. The rest is the same, nothing changes, okay, in our routine. There are these, and this is the only part that changed. Notice that the value is loaded into the 6, then it is moved into the 1, the 2, and the 3, okay, and that is because of the colors that we have, the RGB, no, but as routine it's still the same what we had before. So there's nothing actually to explain. I just wanted to show you that the routine doesn't do anything special except adding that value what we had before to you see the 2 holds the value and we are adding it to d4. So d2 holds the value, that value that for green was I forgot what it was, but whatever it was, we are adding it to the actual value that there is in the table, and then we continue with our routine. You see, we do the logical shift right, then we multiply, then we divide, and then we store. So it's the same routine. We jump back to the book. Okay, so we did that part. I'm going to show you another routine that passes from one color to another. So this is more interesting. Let's say we start with green and we go to blue, or we start with red and we go to green or yellow or something like that. So it's more interesting. Or we start from 0 and we go to white, and that is 8F, which I'm going to show you. So let's jump back to I forgot to put you in the book, but as I said, I'm not going to do anything. There's no explanation here in the book. I'm just saying that we are going to do this example, lesson 8F, where we jump from one color to another. So we go back to the Amiga. We load our next one, which is F. And you're going to see the differences. So we started normally, okay, and then notice what's going to happen. Boom, it went to white and then came back, right? Now notice what's going to happen. From that yellowish it went into green. Notice what's going to happen. It went into blue. From green it went into blue, and then we end. I'm just going to do it again just to what do you mean, how many shades of white? White is just one color, but it can go from black to white using grayscales, and this the basic Amiga had 16 variants using the normal palette. Then you can extend it, but right now yeah, let's say 16. Actually it had 64 and even more, but I will be complicating things. So I'm just going to show you again. Notice that it's we're going to go do a fade in, okay, the normal way. Okay, now notice that from this color is going to flash to white and go back to it. Sorry, this was the fade out. Now notice that it's going to come to life and go to the white and then go back to the normal color. You see? So from black it went to white, and white to our color. Then it went to green, then it went to blue, and then we exit. Okay, now let me show you the code for this. So now I'm going to show you the code, but you see Nemo here, he has a frog. So he does these things. He used to do these things. Am I in the actual code that explains 8F? Yes. So there's one thing that I didn't say. I'm going to jump quickly here. In this paragraph, he says, this code is too complex. Okay, I forgot to read this sentence. This code is too complex for a beginner. Okay, so he's showing us this example of fading from one color to another, but he says we use it. Okay, we can use it, but it's too complex for a beginner, and he doesn't explain it. In fact, the reason being is there is too much maths in it, mathematics, and other things that for a beginner he will get like a he will get a shock. So he gives us the routine and he asks us to use it as it is. We can change the parameters of it, but we don't need to know how it really works, because you will only really understand it once you actually read the book, probably. So yeah, so I am going to show you and to make you aware how complex it is. This is just handling the blue. Notice how huge the code is just handling the blue, and notice also how many times he's doing a multiplication or a division to achieve that effect. It is a bit complex, so I just wanted to show you that once you understand one, you understand the blue, you understand the green, and you understand the red, because they are a copy of each other, but the mathematics involved is quite high. And actually that routine calls another routine, which is a multiplication. Okay, but it's a multiplication and division of 16 and 16-bit numbers. So I will skip this. This is quite advanced 68,000, to be honest. Now we arrived at something that is really nice in the book. So here is the next section. Okay, so Fabio was very happy. Okay, he had some students, followers at that time. Okay, we were talking 1995 or 1996, and they did some code using the book. Okay, so they did whatever they could till chapter 7. Remember, we are in chapter 8, so his students, they are here, allievi, which means students. Okay, they did these three. He's proud now, so he's going to show us what his students did. So I'm going to show you that by going to the Amiga, and we are going to see each one of these. Now I have a note here. Okay, the last one, 8H2, scroll text 8 times 8, the Lorenzo de Gaetano. Lorenzo de Gaetano happens to be a member of Phase 101. Okay, so I am quite, in a way, proud that one of the members got his code into the book back then. So, and he's still a member of Phase 101. I mean, he's still an active member of Phase 101. So let me show you what these three guys did by jumping to the Amiga. So here you are seeing a parallax effect, like what was used in I mean, remember the Shadow of the Beast when he is walking, no? The floor, how it walks, is the same effect. Okay, I mean, I'm not saying it's identical to it, far from it. No, it's but you can see several layers of scrolling creating that parallax effect And this was achieved by what we have done till chapter 7. So I've been saying this many times now. With what we've covered till chapter 7, there's enough material to write a game, okay, or a demo, which I've been showing you lots of bits and pieces of demos, okay, which you can combine them all together and create a demo actually, but yeah. So that's the first example. Let's do the second one. So this is another example, having a control panel, let's say, where we can enable music. For example, you will see it here. And we can also switch it off, okay? We can change the colors of the bars, okay, behind the logo, as you can see. We can move the bar, okay, so let's say that you see it better, and we can change the colors of them. We can change from PAL to NTSC, okay, that is NTSC. As you can see, the lower part of the screen got chopped off, and that is PAL again, okay. We can make the screen go bigger and smaller. You can see it using that effect and coming back. Just going to show you again. These are all things that we've done in all the lessons so far till chapter 7. I mean, this code is all from there. Just they merged it all together and maybe they improved it a little bit, but that's basically it. And we quit and go to the next example, which is of our Lorenzo. So Lorenzo wrote this code, wrote this scroll text in 1996, I think, and sent this to Fabio, and Fabio liked it a lot. Okay, so he put it in the book. So basically, okay, as I've been saying, you should be able to have code or do code similar to this one. We have basically, I think, finished. Let me check the book to make sure that I have said everything that I needed to say. Yeah. Okay, so we have finished. Okay, we have